This is term 2, week 8, chemistry CA. It's the same material as last week, but what's new is just carboxylic acids and esters, and I think polymerization. So you just need to go from carboxylic acids over here. So where's esters? It should be somewhere here. Hold up. Yeah, esters are part of the carboxylic acid section. Okay, we're gonna work off of last week, which we stopped at over here at alcohols. You need to know that alcohols, they're OH. Carboxylic acids, it's basically just an alcohol being oxidized. Okay, so carboxylic acid has the COOH functional group. Okay, you need to know that carboxylic acid. You need to know that it can be made by the oxidation of alcohols. Okay, how? By either oxidizing the alcohol with warm acidified KMnO4, or by bacterial oxidation during vinegar production. Okay, one or the other. Because I'm sure you guys know that bacteria, when they do fermentation, they produce ethanol, and then basically if you just add oxygen to that ethanol, we get the carboxylic acid. Okay, so you need to know this. The ethanol is mixed with acidified potassium manganate and heated. It has to be heated in a round bottom flask. The condenser is set up in a vertical position to prevent the volatile alcohol from escaping. Remember that alcohol is highly flammable, and heating should be done with extreme care and never with a direct flame. Okay, then you need to see the reactions of acids. These are pretty straightforward. We know these. You guys know acids. What do they react with? Metals, metal hydroxides, and metal carbonates. These are from salt preparation, if you remember. Okay. You need to know that the carboxylic acids, like for example, ethanoic acid. How do you know it's ethanoic? Because it has 2 carbons. So eth. Okay. Carboxylic acids are named prefix anoic acid. Okay. So this is called ethanoic acid because it has 2 carbons. Remember, ETH, use eth when you have 2 carbons. So ethanoic acid is a weak acid, okay? It partially dissociates. So why do you need to know this? Because if they ask you which one represents the dissociation, you need to know that when it dissociates, it's a double arrow because it's partial dissociation, okay? Just memorize this. You guys know acids, they react with metals, metal hydroxides, and metal carbonates. With metals, what happens? It releases a salt and a hydrogen gas. If it reacts with a metal hydroxide, it releases metal and water. We know this. And if it's a metal carbonate, it releases, not metal, salt. If it's with a metal carbonate, it releases a salt, water, and carbon dioxide. These are from chapter 3, salt preparation. Okay, esterification. We said esterification earlier, we kind of mentioned it. You need to know that alcohols react with acids to produce sweet-smelling esters. So if you want to produce an ester, it's alcohol plus acid. Okay, alcohols react with acids to produce the sweet-smelling esters. You need to know that esters they have a sweet smell. Okay, this reaction requires a catalyst, which is usually H2SO4. Okay, you need to know this. To name an ester, I don't think we have naming. No type. For example, okay, this is just naming. Okay. Yeah, I won't go over naming, but when we have the periodic table. Then we have fuels. I think we have fuels. Do we have fuels? We don't. Okay, I'll just go through the quiz, and if there's anything that is not covered, I'll cover it in the moment. Question 1, which of the following has sweet smells? We said it's what? Obviously esters, huh? Very easy. Question 2, which of the following are common use of esters? Okay, these are over here somewhere. Hold up. Yeah, if it's not in the notes, we're gonna go over here and just memorize this, okay? So esters are used in the production of soaps, perfumes, and some foods as artificial flavoring materials, okay? Not in fertilizers and not in explosives, obviously. Question 3, which of the following represents the complete combustion of C2H6? So, remember, alkanes can undergo combustion reactions. This is from last week. If you want to do a complete combustion produces CO2 and water, and obviously it's just reacting with oxygen because that's what a combustion is. If you want to balance, you have 2 carbons here. One carbon. So you have 2 here. But you only have 1 here, so you need to multiply by 2. You have 2 carbons. You have 6 hydrogens here, but you need to multiply this by 3. Okay. Now you have carbons and hydrogens are both balanced. You have 4 oxygens here and 3 oxygens here, so you have 7 on the right, but you have O2 here, so what can you do? You can multiply by 7/2. But there's no fraction coefficient here, it needs to be a whole number. So what do we do to get rid of the 7/2? We just multiply the whole equation by 2. Balancing. Okay, this is very easy. Okay. طيب 4 CO2 plus 6 H2O. Why did it become 4? Because I multiplied the whole equation by 2. صح? Okay, so you get the same thing. Question 4. Which ester will be produced if ethanol and methanoic acid react? You're gonna get ethyl methanoate. I'm gonna show you how to name ethers because shaklo you have to know. Okay, it's written here. Let me go up a bit. Before polymerization, before all of this, it was at the end. To name an ester, over here, they said it somewhere. So it's the alkyl group of the alcohol plus the number of carbon atoms of the acid. Okay, so over here, what's the group of the alcohol? What's the group of the alcohol? Eth. So you say ethyl. Okay, and then it's an ester, right? So it has to end with O8. Okay, always esters end with O8. Okay, if it's methanoic acid, then you put methanoate. Okay, so look here. An ester will always have something YL, okay, and then something O8. Okay, the YL comes from the alcohol, and the O8 comes from the acid. Okay, so here ethyl methanoate. Okay, this is how it works. Question 5. Which of the following is the general formula of alkenes? Alkenes, you guys know, is CnH2n. Very easy. And what's the alkene having 2 carbons? Just substitute R with 2. You're gonna get C2. And then H is 2 times 2, so 4. C2H4. Which of the following is the general molecular formula for alcohols? Okay. Alcohols, you need to memorize this, okay? How do I remember alcohols? The general one, they all come from alkanes, which is CnH2n plus 2. Alcohols, they have to end with OH. For what do they do? They steal 1 oxygen, so instead of plus 2 it becomes plus 1. 2 oxygen. They steal 1 hydrogen, instead of plus 2 it becomes plus 1, and they throw that hydrogen over here at the end. Okay, so it becomes like this: CnH2n plus 1 OH. Okay, which one is an alkanol? You're gonna have to see which one has the OH group, right? Because we said alcohols, alkanols, whatever you want to say, they have to have OH. Why is this wrong? Why is this wrong? Because this has C double bond O OH. Okay, this is actually the functional group for carboxylic acids. Okay, remember when I told you have COOH? That's carboxylic acid. Okay, we don't want that. Only we want what? OH. Okay, so over here, it's gonna be the only correct one. Question 7. Chlorine is added to methane. The reaction between methane and chlorine can be speeded up by UV light. This reaction is called a substitution reaction because chlorine takes place of a hydrogen and methane. Type. Remember, we said alkanes, methanes, they can undergo chlorination and fluorination and bromination, right? And for these reactions, chlorination, bromination, and fluorination, it's just adding Cl, F, and Br, right? These 3 elements. But there's a difference. Chlorination, bromination, and fluorination, they both occur in alkanes and alkenes. But the difference between when it occurs in alkanes and when it occurs in alkenes is in alkanes, it's substitution, okay? But in alkenes, you're just adding it, okay? Also, for alkenes, the conditions, it's not required to have light. It was a question last week. Can it occur in the dark? Chlorination, bromination, and fluorination. With an alkene, of course it can. But for an alkane, it must be in the presence of light. Okay? And how does it work? I told you substitution. So how do you substitute? I explained it last week. The one chlorine comes and takes the place of hydrogen, and that hydrogen goes back and takes the place of the chlorine. Select the possible products of the reaction between methane and chlorine. Obviously, it depends how many chlorines. But you have space for 4 chlorines, right? Because you have 4 hydrogens. So it can be this. It can be this. It can obviously be this. Why can't it be this? Because where'd the carbon go? The carbon mamnu yitharrak. Okay, it's not allowed for the carbon to move, and this is obviously wrong. This Yeah, this is correct. You're going to, what didn't you say the carbon can't go? Okay, look, when the chlorine goes here and the hydrogen goes here, what's going to happen? It was Cl, Cl, and you have here CH4, right? When you add them to each other, نحن اتفقنا, we agreed that this will come here and this will go here. طب what's going to look like? It's going to look like this. H plus HCl. You see? So we get this, okay, sure, but they're asking for the product in general. And obviously, since it's a substitution reaction, you need to know in chemistry, every substitution reaction has two products, okay? So, okay, you figured out the first product, it could be that, but you should also figure out the byproduct as well, which is HCl, okay? And why is HH wrong? There's no Cl, there's no C. Someone's gonna come and tell me, what if you took the other Cl and you put it here? You're not allowed, okay? The only time the bonds can be broken is if there's two Cl's together. This HCl, you can't break the bond and put a Cl here because it just won't form, okay? It needs to be a Cl-Cl bonded molecule for the bond to break, okay? Question 8. Ethane C2H4 has the following structural formula. Ethane reacts with hydrogen gas at high temperature at pressure. When ethene, an alkene, reacts with hydrogen, it's called hydrogenation, right? And hydrogenation, it's what? It's an addition reaction, right? Choose the chemical formula after the hydrogenation. طب انت عندك ethene C2H4, you're adding H2, what happens to it? Comes C2H6. Choose the homologous series of the product. C2H6 belongs to what family? Obviously alkanes. Why? Because it's CN H2N plus 2, right? Choose the correct classification of the product of the hydrogenation of ethene. It's going to be saturated hydrocarbon. Someone's going to come tell me, well, you choose saturated. Why saturated? What does that mean? Remember, I always tell you, a molecule can be either unsaturated or saturated. It's unsaturated when it has the carbon double bond. And what's the only molecule that has a carbon double bond in the organic chemistry? It's all the alkenes. فانت هلا when you did hydrogenation and you added the H2, it now became a part of the alkanes. How that works, by the way, is you have CC, carbon double bond, H. This is ethene, okay, C2H4. Always an alkene, any alkene, it has a carbon double bond. You need to know this, okay? It looks like this. You're adding H2. You're gonna tell me, how does the H2 add? Now what happens is you break this double and you send them both here, okay? طيب, فأنت now when you made this product, you got now C2H6. You get this, okay? 1, 2, 3, 4, 5, 6 H. You get C2H6, right? When you do this, you now have eliminated the carbon double bond to add the hydrogen. So once you eliminate the carbon double bond, خلاص, it's not counted as unsaturated anymore. It's not unsaturated. When you have a double bond, it's unsaturated. بس هلا, what's it called? It's a saturated, and obviously it's a hydrocarbon because it has hydrogen and carbon. Okay? Ethanol C2H5OH can be produced from ethene under certain conditions. Choose the reagent that converts ethene into ethanol. طيب, let's say you don't know this. Let's say you don't know that you can produce an alcohol from adding water to an alkene. Let's say you don't know this. But let me explain to you. Let's say you have C2H5OH. You're asked to produce C2H5OH from C2H4. But let's see what's missing. The carbons, we don't have anything missing. The hydrogens, we have one hydrogen missing, and we have this OH missing. What's this? Isn't this H2O, right? And they're saying, people say, what isn't H2O? Water, steam. What's steam? Some people, somehow, in grade 11S, don't know that steam is just water, but in a gas state. Okay? So, when we say you have to add H2O, you're adding water, but steam is just water in the gaseous state. Okay? So, lock in. Okay? Steam is just water. Okay? Why is it in a gaseous state? In case they ask it, it's because if you read in the notes, I explained this last week, that the conditions of temperature and pressure are very high. So it's a very high temperature, so it can't possibly be liquid. Ethene readily reacts with chlorine at room temperature. Look at the product of reaction between ethene and chlorine. Halla, you have an alkene reacting with chlorine, bromine, fluorine. Now you're gonna do chlorination, right? But what's the difference? For alkane, it's substitution, but for alkene, what's gonna happen? It's addition. So our ethene looks like this, okay? Right? You now wanna add chlorine, Cl2. Is it going to substitute? No. Since we have this double bond, what's going to happen? This is going to break, so it's going to allow one to form here, one to form here, and the Cl's are added here. Okay, that's how it works. Question 9. That comes to Alfie. 16. Select the structure of unsaturated hydrocarbons. To have an unsaturated hydrocarbon, I told you, unsaturated يعني carbon double bond. Is there carbon double bond? No. Here is there carbon. Someone's going to tell me, طب وليه isn't it between the H and the C? لا يا حبيبي لا. This is the structural formula. The structural formula, it actually, if you draw the displayed formula, it looks like this. Okay? The H2 is just like to talk about the stuff connected to it, and then double bond carbon. And that's what it means. Okay? So, do you have a carbon double bond here? Yes, you do. Okay. Here is there carbon double bond? No, so it's gonna be saturated. Here it's saturated. Here is there carbon double bond? Yes. Okay. Question 10. Sucrose C12H22O11 reacts with water under certain conditions to produce an alcohol. Give the name of the process that converts sucrose into an alcohol. How do you convert a sugar to an alcohol? We said we do alcoholic fermentation, or they call it just fermentation, right? This is what we did last week. And what's the catalyst? Who does it? The yeast. Which of the following other products of the described reaction? We tell you always, sucrose, it's alcohol plus, as you know, it's an alcohol in the presence of yeast at 25 to 35 degrees Celsius, okay, to produce ethanol plus carbon dioxide. Right? What's it called? Yeah, if I here see any glucose is broken down to produce ethanol and carbon dioxide. Okay, someone's gonna come and tell me, Waleed, طب isn't it sucrose? Okay, in bio, sucrose and glucose are kind of like the same thing. Okay, when it comes to this stuff. Okay, I'm not gonna go into details because like there's no point. I don't want to talk bio. I dropped for a reason. But they work. They both work. Okay. Which of the following are the products? So it's going to be C2H5 and CO2. Choose the method used to extract concentrated alcohol from the reaction mixture. Be careful. Now we produce carbon dioxide and alcohol. So it's not pure. You need to know that it's impure, right? So how do you extract a pure gas from two gases together? You do alcoholic fermentation, as the fractional distillation. Propanoic acid C2H5OOH COH reacts with ethanol C2H5OH according to the below equation. So you have an acid reacting with an alcohol. What did we say that produces? That produces an ester, right? Remember, I told you, carboxylic acid plus alcohol produces ester plus water, of course. We did it earlier. So what is the name of the forward reaction? Obviously, it's called esterification. Someone's going to come and tell me what's the name of the reverse reaction. Here's the thing. In chemistry, you have two types of reaction. You actually have what we call a condensation reaction. Okay. Condensation reaction. Some people also call it dehydration. Okay. And we have the hydrolysis reaction. And some people call it also hydration. Okay. I prefer using these. Okay, these two are preferable. Okay, condensation reaction is when you're mixing two things together, and what do you release? Water. Okay, someone's gonna come tell me, isn't that the same as dehydration? I said yeah. So someone might tell me, why is it dehydration if you're releasing water? Isn't water good? Doesn't that mean you're hydrating? No. What do we mean by dehydration? It means we're removing a water molecule. We're removing a water molecule from the bonds. Okay, we're removing it, we're dehydrating it and releasing it outside. Okay, the reverse. So when you're forming bonds and you're building something, that's called condensation and it's called dehydration if you want. But what's the reverse? If you go the other way around, you're going to be using H2O. Okay, so you can say hydration. To form two smaller molecules. So whenever you're building one molecule, we call it condensation or dehydration. Whenever you're going the other way around and you're breaking down a molecule into two subunits, or not subunits necessarily, two smaller molecules, that's called hydrolysis. Okay, that's why the answer is hydrolysis. Give the name of product A. By the way, someone's going to tell me, why isn't the answer here condensation? Because you're forming an ester, so we call it esterification. Okay, give the name of product A. We need to know the product A. We know obviously it's an ester. How do you name an ester? It's something YL, okay, something O8. We know the YL comes from the alcohol. What's the alcohol? Eth. So it's ethyl. And then the acid is propan. Okay, so we put propanoate. Okay, simple as. Locate the structure of product A. So it's the ester now. They want us to see the structure of the ester. Obviously, it's just going to be these two joined together. It's not that hard. But this one here, this H and this OH, they get thrown away to form water, right? Obviously. Okay, so you just join them together. You connect now this O to this C, and it looks like this. Okay. Compound B has the same molecular formula of compound A. Okay, choose the name of the carboxylic acid and the alcohol that react together to form compound B. So this was actually mentioned in the notes. So ethyl propanoate, it's formed by having ethanol and propane, what was it? Propanoic acid, right? طب هلا they're saying we have one, it's the same formula but it has a different name. What formed it? Take a look. نحن مش we say it's YLO8, right? If it's the same formula معناتها you still have the same like composition but we change the name. So the only way you can change the name is if you switch these two here. So what does that mean? That means for the alcohol, instead of using ethanol, and for the acid, instead of using propanoic acid, I can just swap them. If you swap them, you're still going to get the same formula, but you call it something else. Why? Why do we call it something else? Because to determine, oh, what alcohol did it come from, what acid did it come from. So let's say now I used propanol, okay, and ethanoic acid, okay. What am I going to get here? I'm going to get propyl, and here ethanoate. Okay. Oh no, this is already OA. So if you ever want, they tell you, if you see a question like this, all you have to do is just swap it. We had ethanol and propanoic acid. All you have to do is just swap it. If it's the same chemical formula but different name, all you have to do is just swap them. So swap this eth with this prop, and you're gonna get propanol and ethanoic acid. Okay, as you can see here, the answer is C, which is correct. Question 12. Did I skip any part? Because recently I've been skipping parts in my recordings. Question 12. Two separate samples of ethanol are warmed in acidified solutions of potassium permanganate and in an acidified solution of potassium dichromate, K2Cr2O7. These are both, by the way, oxidizing agents, okay? If you want to produce carboxylic acid. Okay, the two reactions form the same product and can be represented from the following. What is the type? Obviously oxidation, because you're working with O. Let's say you didn't know what's this reaction. شايف O هون يا عمي, so we put oxidation. Okay, this O, this symbol with the O in brackets actually stands for oxidation. If you want to big brain it and whatever, you're adding an alcohol to an oxidizing agent. You should know that both of these are oxidizing agents. It's required for you to know it, okay? You're adding an alcohol to an oxidizing agent. So what's going to happen? You're going to get a carboxylic acid. So this product X, it should be a carboxylic acid. Someone's going to come tell me, what's the carboxylic acid? Look here. This C2H5OH, you started with C2H5OH. So your carboxylic acid should also have how many carbons? 2, right? So it's one here, one here. So someone's going to come tell me, what happened to one hydrogen and where'd you get the other oxygen? ما we're saying it's oxidized. فهي الهydrogen كبيتها لبرا, you threw it outside and you added an oxygen, we oxidized it. So what's gonna happen? It's gonna become like this, CH3. So you're only gonna have total how many hydrogens now? You're gonna have total 4. You know what? I won't explain how the oxidation process goes. I won't explain. But just know, can عندك 2 carbons on? Of course here you're gonna have 2 carbons. Okay? This is how they look. When adding acidified solution of potassium permanganate to ethanol, the color, okay, you need to know this. This is a must. You need to know this, okay? When adding acidified solution of potassium permanganate to ethanol, the color of solution changes from purple to colorless. So you need to know potassium permanganate changes from purple to colorless. And then potassium dichromate, it goes from orange or brown to green. Okay, you need to know this. Question 13. The general molecular formula of a carboxylic acid is this. Okay, you need to know this. So if you want to know, like using this, okay, go to the previous question. We know that it's CnH2n plus 1 COOH. Okay, here's how it works, okay? And our teacher told us this. Until you produce the carboxylic acids from an alcohol warmed with an oxidizing agent, right? طيب, you're going to tell me, it isn't N2? Why shouldn't it be C2H5COH? Okay, I mean, I understand where you're coming from. But here's how it works. You take one less than the carbon number used in the alcohol. Okay, for here, I'm going to take N as 2 or 1? 1. Okay, you're going to take it as 1. So it's going to be CH3COOH. That's how it works, okay? If you want to use the general formula. Question 13, we said this is a general formula. Question 14. A homologous series is family-related compounds that have the same what? Functional group. You need to know. Or they're from the same family. How do you know it's the same family? Same functional group. Well, you need to know these three, okay? They have the same general molecular formula. They show similar chemical reactions that vary in vigor and rate. Similar chemical reactions. Similar chemical reactions. Not same, similar chemical reactions. Did she get it wrong last week? Yes, she did. I don't know why she did. But it should not be same, okay? It should be similar. They can be prepared using similar methods of preparation, yes. They have the same physical state. No, they don't. They have the same density. No. Question 15. Choose the chemical equation that represents a complete combustion of propene. You need to know propene, it's an alkene, obviously, right? En. Okay, CnH2n, right? Type prop, methane, ethane, propan. Okay, so this is how many carbons? 3 carbons. Okay, so let's say you don't have this multiple choice and you ask, give me the combustion of propene. Okay, it's 3 carbons because prop, right? So it's going to be C3H6. You want complete combustion. So obviously you're going to add oxygen to burn and give carbon dioxide plus water. That's how combustion happens. Okay, so what's the first thing you balance? You balance the carbons first, so you put the 3 here. Okay, هلا we have 6 hydrogens, so put the 3 here. هلا you have 6 oxygens and 3 here, so 9. So if you want to make this 9, you do 9 over 2, right? But do we see fractions? No, we don't. So what do? We multiply everything by 2. So come 2C3H6 plus 9O2 to produce 6CO2 plus 6H2. That's it. Unlike propane, the flame produced during the combustion of propene is rather smoky. Which of the following statements best explains this observation? So the answer here is carbon is in a higher proportion in propene. I'm a bit confused because I think it shouldn't be smoky, it should be clean. Please correct me in the comments. I'm not sure. But follow what's said in the quiz. I'll send an announcement on the group if it's wrong. Okay? Please correct me in the comments if I'm wrong. I think if it's a high proportion, then it shouldn't be smoky. I think it should be like I'm not sure. I think maybe smoky they mean like clear. Maybe I think so. خلاص, just memorize it. Why propene and alcohols have cleaner flames than alkanes is because they have higher carbon proportion, and I explained this last week. Question 16. Acid reacts with zinc, which is a metal. What happens when you react a metal plus acid? You get salt plus hydrogen gas. Super easy. Thank you so much for watching. Good luck in your exam.